Hey fam, it's your boy. I'm back at it again. Shouldn't say that. Weird. All right, guys, we're starting a new unit here. This is all about translations, and well, the big topic is transformations, right? It's basically taking a shape, moving it around, flipping it, rotating it, making it bigger, and making it smaller. Actually, shoot, that's what I want to do. Let's see. So yeah, this is our new topic on transformations. This is all about taking a shape and then moving it, reflecting it, flipping it, rotating it, turning it, or making it bigger or smaller. Uh, let's see. Flipping it. No, wow, it really translated rotating it as rotag. Interesting. Uh, there we go. I don't know if that's a great translation, but what are you gonna do? Okay, so the first topic is all about translation. This is all about just moving something, right? Just moving it, left, right, up, or down. It will move diagonally, but that diagonal motion is a combination of a vertical and a horizontal movement, right? Remember, horizontal is left and right, vertical is up or down. Okay. All right. Now this first one here, this is Ashanti drawing a trapezoid, right? We've got this trapezoid right here. You can see it, figure one, figure two. Maybe focus that a little bit much, a little bit more. Um, And yeah, she draws a trapezoid on the coordinate plane, labels a figure one. Then she draws figure two. How can you determine whether the figures have the same side lengths and the same angle measures? So the idea here is we're basically comparing the original here to this one here, right? This is the original shape. This is the new shape. Okay, we have very specific words for this for these kind of figures, right? We call the original the pre image, and the new one, the image. Okay, um, so we've got this here, and the idea here is you want to compare sides and angles. Okay, so if I take this side right here, it matches to this side right here, and practically, let me go grab a ruler, guys. Be right back. Okay. And the idea here is we'll just, we'll actually do the measurement here. We've got this at about 2 centimeters. Okay. And then we compare this. That's just about 2 centimeters as well. Okay. So this side matches or maps to this side. Okay. And then, we'll do this here. That's about 1 3/4, maybe. Just under two for that one. Same right there. I'm not going to label them. That's about 3.5 centimeters. That's about 3.5 centimeters. That matches to that. And then this last kind of diagonal one, yeah, is about 2 and I don't know, 3/7. Yeah, but it looks like they match up, right? And so each side matches to the other side, right? So I could like kind of label them like this to match them up. Okay, so that's one way you can kind of label your sides. And I can also match the angles up, right? This is right here. I can see that those are right angles. I could actually measure them with a protractor if I wanted to, but I don't want to get into the weeds like that. This angle right here matches to this angle right here. So if this is A, then I'm going to call that A prime to distinguish them, right? A is the original pre-image. A prime is the image or the new one after it has been moved, after it has been slid, after it has been translated. Okay. So yeah, let's summarize this, and then we'll go to the vocab page. How could you determine whether figures have the same side lengths and the same angle measures? Well, measure the sides and angles to see if they match. All right. So that's ultimately the simplest way to do it, and that's how you can be sure. Now, this one is difficult because it doesn't really have a grid on it, so you can't really like reliably say, oh, this is at 9 and that's at 2, so that would be a difference of 7 versus 7, right? when it's on a grid, it's much, much easier to match these things up and like measure things. And that's primarily what we'll be doing in this unit, is using a grid for this kind of stuff, right? Now, if we go to the vocab sheet, we're going to fill out the first four boxes here. So transformation is when you manipulate a shape, is probably the best way to say it, because manipulate, covers a lot of different options, right? You can move, flip, turn, or enlarge. And let's just do the very basic vocabulary here. Make bigger or shrink. All right, we're going to use different words for this, as we go through, right? But yeah, you manipulate shape. You can move it, slide it, flip it, rotate it, turn it, make it bigger or shrink it, right? So these are the different things we're going to be doing. It's kind of four of them, right? First one is moving. This is called translation. Second one is flipping. This is called reflection. Turning is rotation, and then making it bigger or shrinking it is called dilation, right? Enlarging or reducing. That's kind of, I know it's two different things because you're making it bigger or smaller, but it's kind of lumped into one category, right? And then in translation, and this is when, oh, dang, Dave, you need to add some vocab boxes. Oh, no, I got it. I got congruent right here. Whew, good Lord. All right, translation. This is when you move a shape without changing the size or orientation. Okay, I think it's pretty clear what it means without changing the size. It doesn't get bigger or smaller when you do a translation. The orientation part might be a little more confusing. It's just, you can think about it as the position of it. Maybe that's an easier way of saying it. But like you can see that I have figure 1 and figure 2 right here. This angle right here is in the same spot as the angle right here, right? And this angle 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 and this angle. They're all in the same positions, right? I didn't take it and like rotate it or flip it to change those positions, right? So this is in the same orientation, okay? So translation doesn't change the orientation or position, it just changes where it is on the grid or where it is on the set of quadrants, I guess. Again, the image is the new shape after a transformation. Okay. And then the pre-image is the original shape before a transformation. Okay. I don't have prime notation on here, I don't think. Do I? Well, we won't worry about it right now. Okay, so those are kind of the four vocabulary words we want to talk about here. I might pop it elsewhere on here. Let's see. All right, well, we won't worry about it right now. Okay, moving on to example number 1 right here. Okay. So this is kind of just like getting the basic concept of translations down. Okay. We've got a landscape architect. They show a plan for a new patio to a client. The client wants the fire pit moved 6 feet to the right and 3 feet farther from the house. Where should the architect place the fire pit? And how will the client's request change the fire pit? So basically, we got our fire pit here. We've got the grid. We want to move it 6 feet to the right and then 3 feet farther away from the house. Okay, so if I kind of count, and when you're doing these translations, really any of these transformations, you want to focus on kind of one point and then move that one point and then see how that changes the other point's position or location in relation to that original point, right? So I'm just going to start with this kind of point right here on the fire pit. Okay, let me move it here. Okay, we want to move it 6 feet to the right, so we'll just say that one box is a foot. Okay, so this point is going to be 6 feet over here, right? So 1, 2, 3, 4, 5, 6. Okay, so let's move 6 feet to the right, but we also want to go 6 feet farther away, right? So this is where that second kind of like, where it makes it a diagonal movement, right? So we've got it 6 feet farther away, and then 1, 2, 3. Okay, so this point, move to here, and then we want to take kind of each other point and do the exact same thing with it. We want to maintain the same distance and direction, okay? So we'll say keep the same distance and direction for each point. Okay, so let's see if I pop that in. It probably wouldn't be bad for me to know how to say something like this in Spanish. Keep the same distance and direction for each point. Keep the same distance and direction for each point. This is not the best translation app sometimes. There we go. Okay. Yeah, okay, that means my distance. Yeah, I could have done that. Okay, cool. All right. So we've got that first point from here to here. Now we're going to do the other point right here. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3 right there. So it'll kind of be kind of off the edge there, but that's fine. And then we'll do that was that point to that point, and then this point. 1, 2, 3, 4, 5, 6. 1, 2, 3. So right there. And then we do the same thing. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So the idea here is that the fire pit moves 6 feet this way and 3 feet to the right. Now they probably should have said 4 feet away, but what are you going to do? Not everything's perfect. Okay. So we can see that it went this way and this way. Okay. And you can see that it's, since we have the grid, we can count it. We've got 1, 2, 3, 4 right here. 1, 2, 3, 4 right here, 4 here, and 4 here. So it's the same size as the original fire pit. 1, 2, 3, 4. So we can see that it maintained the size and the shape as it moved, right? So this part right here, how the client's request changes the fire pit, right? The client's request did not change the size or shape of the fire pit. Okay, and that's an important point. We're going to keep coming back to this concept right here, where these transformations do not change the size or shape. Okay, and so what that is, or what that concept is called congruence, right? So if something is congruent, right, it's the same size and same shape. Okay, so I know my lines are kind of wonky here, my bad, but you can see, hopefully, if you kind of just count it, that it's 4 by 4 by 4 by 4, right? So this fire pit and then the fire pit here, I mean, I know you're actually taking the fire pit and technically moving it, so it's the same fire pit, but the idea is that if you're just showing it on a graph or on a drawing, right, you have the original fire pit here and here, they are the same, right? They're the same size and same shape, okay? So that is congruent. So we're going to add that onto our vocab sheet right here. And so congruent is when a shape is the same size and shape as a different shape. I know there's a lot of shapes in there. But yeah, okay, so congruent when a shape is the same size and shape is a different shape. Okay, so this goes back to the idea of the image and the pre-image, right? The pre-image is the original shape. So if we look kind of at example, or sorry, to solve and discuss it right here, we can see that figure 1 and figure 2, they're the same size and the same shape. So we could say figure 1 is congruent to figure 2. So that's the idea here. Okay. All right. The clients also want the small table below the window moved 5 feet to the right. Where should the architect place the small table? Draw the location of the table on the plan. Okay, on there. Okay. Okay. So the table's right here. I know it's kind of hard to see. You can see it easier on here, right? Than on here because the grid kind of interferes with it. But basically, it's like right there. That's the table right there. And so the client wants it moved 5 feet to the right. So again, we're going to look at each point, right? We're going to do each point, right? So I'm going to take this point right here and I'm going to move 5 feet to the right. 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5. And then this point, right? Well, let's do this one. It's going to match up to that one. And then it's like kind of 1.5 away. So kind of right there and right there. So again, my lines are kind of wonky, but you can see that we've taken it and we've moved it that way, like that, okay? So where should the architect place the small table? Draw the new location on the plan, right? So we moved it to the right. So kind of just another example like that, okay? Hold on here. Okay, example number 2. This is when we kind of get into the like the grid and the math and kind of like these traditional type problems. Okay, now the translation might be kind of wonky because of all the notation in here and the parentheses, but hopefully it'll work out. So polygon ABCD has vertices at A, B, C, and D. This should be just one negative right there, not two. I think that was a typo. Graph and label the vertices A, B, C, D, and A prime, B prime, C prime, D prime, its image, after a transformation of 8 units down and 3 units left. So the idea here, right, there's a lot to unpack here, right? We've got our polygon right here. We want to move it 8 down and then 3 units left. So there's 2 things happening right here, right? It's going to result in a diagonal movement, but it's kind of 2 separate movements that are happening. We're going to do the 8 units down first, and then we'll do the 3 units left next. And another important thing is that we need to label the new shape. We need to label the image, okay? So we've already got the pre-image labeled, and we need to make sure that we label the image, the new shape, after we draw it, so that we can tell them apart, basically. Okay, it's going to be pretty easy because it's being a different color, but you got to be sure that you label things with this notation. This is called prime notation. And that's the vocabulary word that I forgot on the vocab sheet. So we'll probably add it on the end at some point. Okay, so prime notation, that's what it looks like, right? That's how you kind of tell the difference between the pre-image, the original, and then the new one, okay? So we're going to do it point by point, right? So we're going to go 8 units down and 3 units left. So I'm going to start with A, okay? 1, 2, 3, 4, 5, 6, 7, 8, and then 3 left. 1, 2, 3. And then I label that with the new, with the prime notation, okay? And then B, same thing. 1, 2, 3, 4, 5, 6, 7, 8, and then 3 units left. 1, 2, 3. You'll notice that I'm not putting a point where that change of direction happens, because if you do that, it's confusing because then you have an extra point on there that doesn't mean anything. All it signifies is that that's where you change direction, which is not important, right? For our purposes, okay? So yeah, don't put that point at that transition where you kind of make that right turn, okay? Or that left turn in this case. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So that's our third point right there, C prime. And then D. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. That's D prime right there. And now, so there, my lines aren't quite so wonky. I'm going to use a ruler. I would encourage you to use a ruler as well for all of these, so that your shapes look halfway decent. Okay. And just because it is a different color, it is pretty easy to tell which is the original, which is the new one, the pre-image and the image. But you got to make sure to label it anyway, just in case it's not a different color, right? And yeah, like what if I gave you this? I just gave you this, but instead of purple, it was the exact same shade of kind of like gray that you had right here, and the only thing you had that was different was that prime notation. And the only way you would be able to tell me which is the original and which is the new one is that difference between that A and that A prime, right? So it is important that you label like that, okay? And again, right, we can see that we have, just looking at it, right, we can see that it is the same size and the same shape. We could measure all the sides of it and we could measure the angles, but it's pretty easy to tell if you've screwed it up because your shape looks wonky. It does not look like the original, right? So it's pretty easy to eyeball these and make and determine whether they are congruent or not. Okay. All right. Example number 3, describe a translation. So this is basically working backwards. So a translation has already happened, and I'm asking you what the rule is, like how far did it move, basically. And there's a couple ways to kind of show this. Okay. All right. So we've got our original here, and we've got our, sorry, I should start using the vocabulary. We've got our pre-image here and our image here. I know that, a couple of reasons. I know that because this one has the prime notation on it and this one does not. And also you've got these like arrows telling you. You're not always going to see those arrows, right? In fact, I think this is probably the only time you're going to see those arrows indicating what happened, okay? But I do like this because it's saying match S to S prime. Okay, those are kind of the matching points. So this is how you determine what the rule is, how far it moved, right? If I'm going from S to S prime, right, I went 1, 2 to the right and up 2. Okay, and I can double check my other points here, right? R is kind of in the middle, so over here and then up there, right? And then Q is the same thing, right? It's over 2. Is that right? Or is it 1.5? It's 1.5. No, my bad. It's 1.5. Yeah, sorry, 1.5, 1.5, right? No, it's over 1.5 and up 2. There you go. That makes more sense. Okay. And then R is over 1.5 and up 2. Yes, there we go. That's it. 1.5 and then yes, yes, yes. Okay, there you go. Okay, so we moved right 1.5 and up 2. So 2 ways we can show this, right? You can just write it out, right? You could say we moved 1.5 right and 2 up, right? You could say shifted. You could say translated. And you could say slid, right? So there's a couple different ways that you can kind of tell what is happening, right? So we moved 1.5 to the right and we moved 2 up. Another way you can show this is using arrow notation, right? And the idea here, and a couple of you guys saw this in the Desmos app yesterday, right? But we always show our X first, and then we tell whether we're adding or subtracting to it, right? That X-axis is that horizontal, right? So the X-axis controls whether you move left or right. In this case, we are moving right, so we're going to be adding, okay? And we moved right 1.5. So we would say all our X values are shifted to the right 1.5, and all our Y values are shifted up, so we're going to add 2. Just like that, okay? So yeah, 2 ways to show it. Is that arrow notation? Anyway, that's 2 ways to show it with different notation like that. Yeah, I don't know. I think that covers it pretty well right there. Covered prime notation, congruence, talked about writing a rule, talked about actually doing translation. Yeah. Solid. Okay, guys. Make sure to put this in your your binder or your folder or your notebook, and then also keep a hold of your vocab sheet as well. Okay. All right. Have a good day.